Well, I've created this little video to help those of you who have not had calculus yet to know how to take a derivative of a polynomial. This is very typical when you start out in a calculus-based mechanics course to have to take a derivative when you're doing kinematics. So you may have no idea what that means, and I'm going to show you just the nuts and bolts process without going into why these little tricks work. That's something that really is your calculus teacher's responsibility, but we do not need to know that to be able to use these things in a physics class. So I'm going to imagine that we have some polynomial function here. I'm going to make something kind of ridiculous just so you can see several times what the process looks like. So typically in math, you're going to have maybe y as a function of x, but I'm going to write this the way physics people write it. So I'm going to write x as a function of t, or we use x for position and t for time. That's why I'm using these. So imagine we have a function that looks like this. Now I like to write functions, x is a function of t, just like that. You've probably seen that before in math class when you've done function work. So imagine we have a polynomial like this. 5t to the 8th minus 4t to the 5th plus 16t squared minus 11. Just kind of making up numbers. So what we're going to do is take a derivative. And we have different symbols for this. I'm going to start with a pretty typical symbol. The derivative of a function x, where the variable is t, is written this way: dx dt. The d is actually a short version for delta, the Greek letter delta, which means change. So what this function is doing is it's describing how the other function is changing with time. So when we're up here looking at different values of the x as we change values of t, are our x values changing a lot, or are they changing just a little as we change t? And that's what we're going to be finding down here when we find dx dt, or the derivative of x with respect to t. So for a polynomial, the process looks like this. If you have 4 terms the way I do, you're just going to do one term at a time. If you have 20 terms, then you have to do 20 different derivatives. And the operation between each term just gets brought down and becomes part of the operation of your derivative function. So we're going to start here with the 5t to the 8th. And what we do first is we look at the power of our variable, the power of t. In this case, it's 8. That is going to become a new coefficient. Now, we already have a coefficient of 5 here. Well, we're going to have the 8 along with the 5, and they're just going to be multiplied together. So I'm going to write it explicitly this way: 5 times 8. And then we have the power being reduced by 1. So instead of 8, we're going to change it to a 7. So we have t to the 7th. That is the derivative of the first term of that function. Now we're going to clean that up in just a minute, but I'll leave it that way. Just as you get used to seeing this, you'll be able to kind of tell how I got those numbers. So we bring the operation down, it's subtraction here, and then we'll do the same thing here, 4t to the 5th. So I need to keep the 4 because that coefficient just gets brought down with the derivatives function. But I need to add another coefficient that used to be the power. So that's 5. And then I'm going to lower the power of t by 1. So instead of raised to the 5th, we're going to be raised to the 4th. So t to the 4th. And then in a similar way, we do this other term here. I'm going to add that term. So instead of 16t squared, we're going to have 16 times 2t to the 1st. And I typically wouldn't write a power of 1, but I'll do that again as you're learning how this works. And then minus 11. Now you notice here the 11 doesn't have a t with it. So we'd have kind of like t to the 0. And you might be tempted to say, oh, I see a pattern here. We're lowering the power by 1. So a 0 will become a minus 1. But actually, if you think about what I described a derivative describing, and that is how something changes, how does 11 change? Sort of a trick question, because 11 is a constant. It doesn't change. So the derivative of any constant is 0. So I'll go ahead and write here minus 0, although I wouldn't put it in the final form. So if I clean this up and I write the derivative in kind of a final form, I'm going to have 40 t to the 7th minus 20 t to the 4th plus 32t. And that's about as cleaned up as I can make it. So that is the derivative of this function of x. Now, you can play this through as many times as you want to do that again. I think what I'll do is, imagine we're in a classroom. I'm going to give you an exercise to do on your own, and then I'm going to recommend that you pause the video and then come back. Spoiler alert, I am going to give the solution to this. It'll be a little quicker than the first part, but at least you'll be able to kind of check yourself and see how you're doing. So let's take another function of x. Imagine this time x as a function of t is described as 0.5 t to the 3rd minus 2t plus 4. So using those steps that I described before, stop here, take the derivative yourself, figure out what your answer is, clean it up real nice, and then turn this back on and I'll reveal the answer for you. Okay, so let's see how you did. Didn't really make too much different here. I gave you a decimal number. That's about as complicated as I got. So did you remember to write dx dt? That tells people that you're taking a derivative. It's very important to do that. It's kind of like when you're showing somebody how you got one number from another. It helps in math class to just write what your operation is. This is considered a function, kind of like a square root function or a cosine or tangent or a cubing function. So in the first term here, we would have 0.5 times 3 times t raised to a 2 instead of a 3. So when we put all that together, we get 1.5 t squared. Then we're going to do subtraction. And this is just 2t to the 1st. So, I didn't have one of those with a power of t just in the first one. But t to the 1st can be lowered by 1. But t to the 0 is equivalent to 1. So in this case, we just get 2. And then we ended our function with a plus 4. Plus 4 is a constant. When we take the derivative of a constant, we just get 0. So we don't include that in our final derivative. So the simplest form, as I've written here, 1.5 t squared minus 2. So I'm going to stop here just to leave it kind of short. But then if you need more practice, there are tons of practice websites that you can find where you can go through this, or certainly other videos, or you find a teacher in a classroom to help you out. Good luck.